Good morning, students. In lower classes, you have studied about various types of motion. Let's see if you are able to make out the type of motion shown by me. Let me give you one very simple example. When you were small, you must have enjoyed a ride on merry-go-round number of times. So I have made a small merry-go-round for you. Now, if I consider that you are sitting at this point on the merry-go-round. Now, if I rotate this merry-go-round, you start moving in the manner as shown here, right? So while you are enjoying your ride on the merry-go-round, you are exhibiting which type of motion? Yes, you guessed it right. It is a circular motion, right? So when is the body said to be in circular motion? It is when the body is moving in a circular path. So we have a term here that is circular motion. So when is the body said to be in circular motion? A body is said to be in circular motion when it is moving in a circular path. So say, I consider this to be a circular path. Now this circular path can be considered to be made up of infinite number of sides. Now in order to understand this, let's take a very simple example. Say I consider that an athlete is running along. An athlete is running along a square track. So I have made this as a square track. Let me name it as A, B, C and D. Okay. Now while he is moving in this square track, we consider that he is moving in a way that he is covering equal distances in equal interval of time. Now when I say equal distances in equal interval of time, that means he is moving with uniform speed or constant speed. So now if I consider here that he starts from A and comes back to A after covering one full square track. Now tell me, when he is moving from A and coming back to A, how many times has he changed his direction? Now if I consider here at point A, when he is at point A, he is facing towards B. This is first direction. When he reaches B, he has changed his direction towards C. When he reaches C, he has changed it towards D. When he reaches D, he has changed it towards A. So how many times has he changed his direction while moving along a square track? That's right. He has changed it 4 times. Alright. Now, let us consider that I increase the number of sides and I move to the next shape. Say I consider it to be a hexagonal shape. What I am doing is I have increased the number of sides and decreased the length of each side and I get a hexagonal shape. So now I consider that he starts from A and comes back to A. Alright. Now in this, while he is going in this direction, how many times has he changed his direction? Now since hexagon has got 6 sides, so he has changed his direction 6 times. Now further, if I go to octagonal path, right? Now you know octagon has got 8 sides. So when he moves along an octagonal path, he is changing his direction 8 times. Now if I continue to increase the number of sides and at the same time decrease the length of the side, then a time will come when a body will move in a circle. Alright? Now, when a body is moving in a circular path with uniform speed, it is said to be in uniform circular motion. So that is the next term. Right? Now, since in a uniform circular motion, the body is moving with a constant speed or uniform speed. Is it that it is moving with uniform velocity as well? Now, if I consider, now let me come to a circular path wherein we said that it is moving with a uniform circular motion. Now, we know in a uniform circular motion, it is moving with uniform speed. Now, my question is it moving with uniform velocity as well? All right. It is not moving with uniform velocity. Why? Because we have already studied that velocity can be changed by changing the speed, by changing the direction, or by changing both. Now, in this particular case, the speed is constant. But what is changing at each and every point? It is the direction. All right. Now, how do we come to know about that? Now, say I consider that the body is at point A. When the body is at point A, it is facing this side. Right? When the body is at point A, it is facing this side. If I consider that it is moving in a circular path in this direction. Right? So it is facing towards this. Now, when I come to say point B here, at point B, it is facing towards this side. I consider point C. At this point C, it is facing towards this side. Similarly, if I consider say point D over here, it is facing towards this side. Now, since at each and every point the direction is changing, so the velocity is also changing. And when the velocity is changing, a body is said to be accelerating. So this uniform circular motion is said to be an accelerated motion. We tend to give you this as a 1-marker question. Is uniform circular motion an accelerated motion? Yes, the uniform circular motion is an accelerated motion. Why? Because in this, the direction is changing at each and every point. Since the direction is changing, so the velocity is changing. And as a result, the body is said to be accelerating. So if you take up any body that is moving in a uniform circular motion, it is said to be in accelerated motion as well. So if I consider the example of satellite moving around the earth, it is said to be an accelerated motion. Similarly, earth moving around the sun, it is said to be an accelerated motion. Right? Now, let me consider another example, which again, this activity you must have done many a times when you were small. The activity is, say you tie a stone to a thread and spin it, all right, or whirl it. Now when I do so, say I am holding this. Now when I do so, it moves in a circular path like this. All right. Now, when it is moving in a circular path in this manner, it is changing its direction at every point. Now, when it is moving in a circular path, there is a force that is needed to move it in a circular path. And that force which is needed to keep the body in a circular path is called as the centripetal force. Is called as the centripetal force. So what is a centripetal force? Centripetal force is one which keeps the body in a circular path. Now if I consider once again the example of a stone which is tied to a thread and is being spinned or whirled in a circular path, as I took up this particular one. Alright, now when I'm moving it in a circular path, this centripetal force is acting towards my hand. Alright, now when you also do this activity, you will feel that it is acting towards your hand. So I can show it over here that the centripetal force is acting towards the center where my hand was there. So this is the direction of the force. If I release it at any point, in which direction will it go? Now, if I consider that I release it at point A, which is shown over here, if I release it at point A, which is shown over here, and I consider that the body is moving in this path, alright, then it will get released tangential to that point. Now here I've used word tangential. So you need to know what is a tangent. You must have studied in maths. A tangent is a line. If I draw a circle over here, a tangent is a line that touches the circle at one point. That touches the circle at one point. So here also, if I consider at point A, if I leave that stone at point A, it will take up the tangential path and then it will fall towards the ground. Now similarly, if I consider point B here, alright, if I release it at this point, now when I say if I release it, means I'm removing the centripetal force which was keeping it in the circular path. Alright, if I release it over here, again it will fall tangential, that is in this manner. Okay, now say I release it at this particular point. Say this is my point C. Okay, now since it is moving in this direction, it will be released in this manner. So whenever a body is moving in a circular path, if we remove the centripetal force, that body tends to follow a tangential path or it flies radially. Right? So this is the force that is acting when the body is in a circular motion. Formula to calculate speed in a circular motion. Alright, now how do we calculate that speed? Say I consider that body is moving in a circular path of radius r. Alright, body is moving in a circular path of radius r. It starts from point A and comes back to A. Now we are going to find out speed. Now you know the formula of speed is equal to distance upon time. Okay. Now what will be the distance here? The distance will be the circumference of this circular path. And circumference of the circle is given by 2 pi r divided by t, that is time, and speed we know is denoted by v. So this gives me the formula for calculating speed when a body is moving in a circular motion.